What is depth first search? Depth first search is a graph traversal based algorithm. What is a graph? Graph is a nonlinear data structure which consists of vertices and edges. The ones here in circles are the vertices, and two of these vertices are connected by an edge. Okay. Now, what is graph traversal? Graph traversal is a process of exploring each of these vertices. You explore all the vertices in a graph, and this process is called as graph traversal. We have various applications for graph traversal, like finding the shortest distance between two vertices, finding if there are loops in the graph, and so on. Now, we'll discuss about depth first search, which is one way to implement graph traversal. In depth first search, we essentially think of ourselves as a bold explorer. You start from one vertex, and you're bold enough. You go to the next vertex, and you'll never come back to the previous vertex. Like, if you have an unexplored vertex, you'll be going to the next vertex, and you'll not go back since you're bold. I'll explain you in this example. So, let us start with vertex 1. I'm at vertex 1. So, I have two neighbors here, 2 and 3. So, since I'm at 1, I've explored the vertices which are neighboring this vertex, which are 2 and 3. What I'll do, I'll put 1 in the stack here. This is the visited stack, and the other one is the neighboring stack. I've explored 1, I've put 2 and 3 in the neighboring stack. What do? I explore the next vertex. From 1, I'll go to 2. From 1, I'll go to 2. From 1 to 2. Now I'm at 2. Now I'm going to explore what are all the vertices neighboring 2. I have vertex 1, I have vertex 3 and vertex 6. But 1 I've already visited, so I'll not go back to vertex 1. I can either visit 3 or 6. So 2 I have put in the visited stack. 3 and 6 are the two vertices which I have to explore. So I put 3 and 6 in the stack below. Now I have two choices, 3 and 6. Let me go to 3. I come to 3. I'm currently at 3. I've already explored 1. I've already explored 2. Now I'm at 3. So put 3 in the stack here. 3. There are 3 vertices which are neighboring 3. 1, 2, and 4. What do? 2 I've already visited. 1 I've already visited. So I'll go to the next vertex which I haven't explored. That is 4. Now I'm currently at 4. So so I've visited 1, 2, and 3. 4 and 6 are the ones in the stack. There's 3 and 6 here. 3 was visited here, so there's 6 remaining. After 3, 4 got into stack. So 4 and 6 are in the stack here. Now from 3, there's only one vertex which is unexplored, which is 4. So I'm going to 4. I'm currently at 4. So I'm currently at 4. So I explored 4. What are all the surrounding vertices? There are 3 and 5. So 5 comes onto stack and 4 is visited here. Now that we have explored 4, we'll explore the next vertex. We'll go to 5. We have explored 4, so we'll put 4 in the explored vertices or the visited vertices. 5 and 6 are in the stack. We'll go to 5. So we'll put 5 in the visited vertices. There's nothing connected to 5. So what do? We go back from 5 to 4. There's nothing new vertex to be explored at 4. There's no new vertex connected to 4. So what do? We move from 4 to 3. There's no new vertex at 3. So we go back to 2. From 2, we see if there's any other vertex it is connected to. Yes, I did not explore 6. So there's 6. So I'll go from 4 to 3, 3 to 2, and 2 to 6. So I'm now currently exploring vertex 6. So this 6 which is in the stack will come in here. So we have 1, 2, 3, 4, 5, 6, and this is empty. From 6 we'll see if we have any other node vertex connected to. There's nothing, so we go back to 2. From 2 we'll see if there's any other vertex connected. There's no new vertex to be explored which is connected to 2, so we'll come back to 1. So we have started with 1, explored all the vertices and came back to 1. This is a depth first search algorithm. Now I'll be discussing the pseudocode for depth first search. First, I'm initializing a list called visited with false. So if I visit a particular vertex, I'll be changing the state from false to true. G of length is the total number of vertices. We should observe that this algorithm is recursive in nature. That is, if I'm at a particular vertex, what am I doing? I'm exploring it. What do I mean by exploring? I'm essentially looking at the vertices it is connected to and going to the vertex which was not previously explored. If I'm at 1, I was looking at 2 and 3, and I didn't visit 2, so I visited 2. From 2, I had options of 1, 3, and 6, but 1 I've already explored, so I've gone to the next vertex which was not previously explored. So it is recursive in nature. What do? I start off with an initial vertex. Here in our case, in our example, it was 1. So 1 dot visited, I changed the state to true. What did I do after that? From 1, I was looking at its neighbors. For all the vertices in neighborhood of 1 dot neighborhood, I'm checking if they are explored or not. Since 2 and 3 are not explored, I'll visit one of these vertices. V dot visited. So 2 dot visited is false. So it will be explored. Next, what do? It will go back in the loop again. Next, from 2, DFS of G, 2 will be there. DFS of G, 2, again it will go through the same loop. 3 is not explored, so it will go to 3. Or 6. Whichever is top on the side, it will go to the same thing. So like this, because of this recursive nature, it will go through the entire graph. It will explore all the vertices. And this is how the algorithm works. Thank you.